so let's do some addition with base 2 numbers. So let me make a long base 2 number and another long base 2 number. Adding. So this algorithm works exactly the same way it does in base 10, except you carry faster. You can carry a lot more of the time. So you say to yourself, okay, what's 1 plus 1?
0.
1 plus 1 is 10, right? 1 plus 1 is 2, right? But 2 doesn't exist in this system. So you write down 1, 2, and no 1s. So you do 0, carry the 2. Right?
Okay.
Then you do 1 plus 1 is
10.
10. So you put down a 0, put a 1. Uh-oh.
11.
1 plus 1 plus 1 is 11.
Right. And 1 at the bottom and 1.
So there's a 1 at the bottom and a 1 at the top.
10.
That's 1 plus 1 is 10. So you put down a 0, you carry a 1. 1 plus 0 is 1.
Yay.
And 1 plus 1 is 10. Cool. Check, done. Do I have any idea what 2 numbers I added?
Probably not. I mean, we figure out.
Not really. They were base 2s, right? So if I was doing good notation, I'd have base 2s on these. You guys see this? Sometimes people will omit the 2s or the 10s or the 16s if it's kind of understood what they're working in. Some languages, like computer languages, have markers for those things. That's basically down to language. You guys cool with that? Most of the time, the binary will only exist in the machine code. And so I'm basically showing you how it works, right? And then we probably won't ever use the binary. But the hex is useful sometimes, mostly for colors and stuff.
So by 10, you just meant like the base cap.
Yeah, by 10 you mean you have 0 1s and 1 of the base cap,
Cool.
right? And so by 11 I mean I have 1 of the base cap and also 1 left over. That's cool with that? Okay. Let's see, how would you multiply?
Oh, now we're getting the fun stuff.
So if you had like this and you wanted to multiply by 1 0,
And distribute it, wouldn't it? Each one would be distributed.
okay, yeah, you could think about this in terms of distribution. It's probably easier just to use the algorithm you know and love.
Add a 0.
So 0 times that crap is 0, right? So I'm doing 0 times 1 is 0, 0 times 1 is 0, 0 times 0 is 0, and 0 times 1 is 0, right? And then I put a 0, and then I do 1 times 1 is 1, and 1 times 1 is 1, and 1 times 0 is 0, and 1 times 1 is 1. And then I add these together in the base you're in, right? And 0 plus this is 1, 0, 1. Oh, and that was really dumb, right?
Yeah.
Why was it dumb to multiply by 10? You know how multiplying by 10 works. You just slap a 0 on the end. Doesn't actually matter what base you're in, because it's kicking the base up by, like, you're multiplying through by 1 extra power of the base, right? So that's just going to scoot this whole thing along one place. Okay, see that? So again, all of these are base 2 numbers. Right? So shall we multiply by something more exciting?
Sure.
So let's try it. Same number multiplied by 11.
Oh.
Whoa!
It's going to be 1, 0, 1, 1.
Okay, so 1 times this number is that number,
And then a 0.
and then a 0, and then
Where's that number?
another copy of that number. Oops, a copy though, not a bad copy, an actual copy. And then you add together, right? So you get 1,
0.
and then 1 plus 1 is 0. Carry the
0.
carry the 1, carry the whatever. So
10.
then you get 10. Carry the 1. That's 10, carry the 1. That's 10, carry the 1. Cool. Base 2, base 2, base 2, base 2, base 2. Cool. This is one reason why the algorithms that we teach you are convenient, right? Because you just do the same thing. The only difference is that you have to know how to carry, right? So carrying in base 2 is just a tiny bit different. Otherwise, it's basically the same thing. The nice thing about bases smaller than 10 is that you know the multiplication tables already. Does that make sense? That you already know how to multiply those numbers. You already know how to add those numbers. Once, if you make it hex, then you have the numbers 0 through 15, and you probably a lot of your multiplication tables only go to 11 or 12. Does that make sense? Probably a lot of you can't tell me off the top of your head. Quick, what's 13 times 15? See. Quick, what's 7 times 8?
195.
Paralyze my fear.
Damn it.
I think it's
Okay.
195.
Yeah, but you'd have to like spend a minute figuring it out, right? And worse yet, it's going to be letters when we get there. Cool. Everybody good with base 2 operations?